you don't have to rush too much. I'll let you figure that out. You can work it out by hand, or you can do it in your calculator. Austin, I accidentally printed you a dozen. I don't think you need that many, do you? No, that's okay. Am I correct in thinking I did not hand out the homework paper copy in here yesterday? Okay, so if you would like one, I can give you one now. Go ahead and get out the homework as well, too, when you're done with these, because we need to go over that. So get out what you did on whatever other paper. And I think the key was posted, wasn't it? Yeah. Okay, so hopefully you already checked. People at home, are you seeing a little sign that says do that ticket in the door? Oh, no, you're not. I just got that. Thanks. Yeah, you're not supposed to be seeing just a black screen. Folks, always feel free to ask. Always ask. You should be doing the ticket in the door. It's posted on your today. It's posted on, I was just making a sign so that people could see that as they were still coming in. Ticket in the door. It's posted on today's classwork. Okay, give me about one more minute. Okay, one of the reasons that we like to use exact form for these is that it can be very, very easy when you do. Problems number 1, 4, 6, and 7, all of those you should be able to just write the answer with no calculation whatsoever. Okay, so if you're not to that point yet, realize that that's one of the goals. Is that on problems like 1, 4, 6, 7, there's really nothing to calculate. You just write the answer. Okay, 2, 3, 5, and 8, there's a little bit of calculation. So let's go ahead and check. Here are the answers you should have gotten through for 1 through 4. And you could see 5 on there. Check, let me move it over. You can see 5 and 7. Check your answers. Okay, and here's 6 and 8. Questions to go over. Caroline. Number 3, okay? Okay, so first off, yes.
Can you also go over number 5?
Sure.
Okay, thank you.
First off, numbers 1 through 4 are all about 45, 45, 90s. So remember, this was in the video, basically just a real shortcut way to remember what numbers to use. If it's a 45, 45, 90, the only number I'm going to use is square root of 2. If I'm going from the leg to the hypotenuse, I'm trying to get bigger, so I'll multiply by square root of 2. I'm going from the hypotenuse to the leg, trying to get smaller, so I'll divide by square root of 2. Now, if you have the kind of calculator that was suggested in the syllabus, sorry about that, let me turn it off. This is number 3. The hypotenuse is 4. We're going to divide it by square root of 2. It'll give you the simplified radical form of the answer. Boom. Okay. That's what you do if you're going from the smaller to the larger, from the leg to the hypotenuse. Now, if you don't have that type of calculator, it's not that hard to calculate it. If you want to divide something by square root of 2 or by root 3, you write it as a fraction. Then we go ahead and rationalize the denominator by multiplying by that radical over itself. That gives me this. Now, the rule for dealing with radicals with multiplication and also with division, okay, is that children outside the house play with other children outside the house, children inside the house play with other children inside the house. That's the easy way to remember it. Okay, the house here's the radical. If you want to multiply expressions that have radicals and have numbers that are outside the radical, it's the ones outside that will deal together and the ones inside will deal with each other. There's only one number under a radical here, so that's not going anywhere. The 4 over 2, 4 divided by 2, I can do, and that's 2. So that's how we get to root 2. Okay, same concept happens in number 2 when we're multiplying. You have a leg. Okay, we have to multiply by square root of 2. And again, children outside the house deal with other children outside the house. Children inside the house play with other children inside the house. So the 3 and the 2 can play together and make 8. I mean, not 8, excuse me, 6. And that's what I get for my final answer for the hypotenuse. Okay, on number 5 and beyond, we're dealing with 30, 60, 90s. So depending on what we're moving between, we're either going to use the number square root of 3 or we're going to use the number 2. We don't ever use square root of 2 with the 30, 60, 90 triangle. These are the only two numbers we would use. Okay, so on number 5, first thing I have to decide is what leg was given, or leg or hypotenuse, what side was given to me. This is the short leg. Okay, so once I decide that that's the short leg, everything else has to be bigger than the short leg. So that means I'm going to have to multiply to get to anything else. Smaller side to bigger side means multiply, bigger side to smaller side means divide. So short leg to long leg, I'm going to multiply by square root of 3. Short leg to hypotenuse, I'm going to multiply by 2. So 4 root 2 times square root of 3. These are my children inside the house, and that gives me 4 root 6. 4 root 2 times 2. 4 and the 2 over here are outside the house together, so they play together and give me 8 root 2. So that's how I get these two numbers in number 5. Okay, other questions to go over here? Make sure I'm seeing any chats. Yeah, feel free. Okay, so everybody good with the rest of those? Any questions from the homework? The key was posted. So any you want to go over? One question I wanted to ask you. I told you the key was wrong on number 11 on the 30, 60, 90 one. Okay, number 11 on the 30, 60, 90. I pointed out the key was wrong on that one. What should the key have said on that one? What'd you get for number 11 on the 30, 60, 90 side? It's not like it was a complicated problem. I just didn't finish it. Alex? Okay, so what would you get in exact form, though? There you go. I just stopped too soon on the key. I stopped right here. When I had that little piece of the bottom, when I had the short leg of the 30, 60, 90, I went ahead and wrote that as if that was the answer. That is not the answer. They were asking me the length of the side of the equilateral triangle. So that's the 12 root 3. Okay. Other questions? Or comments or anything else to look at on the homework? Okay, so we are jumping into right triangle trig starting today. And there is a packet or multi-page document on Google Classroom. Everybody at home, go ahead and go open that up. If you've printed it out, great. Go ahead and get that. And I'm going to go ahead and hand that out to people in the classroom. Let me point out both for the people at home and for the people in the classroom. If any of you did not already check your whole homework, okay, please go ahead and make use of that key at some point and check it, and then you can ask me questions if there's anything on there, or you could try again. Try again first and ask me questions if you can't get it. Okay, so trigonometry. Trigonometry is basically the study of measures of triangles. That's what it means. Trig, 3, triangle. Metry means measure. So that's what it is, triangle measure. All right, so just like in this, when we were doing this, we talked about this as the short leg and we talked about this as the long leg. We sort of renamed the parts of a triangle to suit our purposes so that we could refer to them in a way that related to what we needed to do with them. Same thing's happening here. We're going to call the three sides of our right triangle the hypotenuse, the opposite, and the adjacent. Now, the hypotenuse is always the hypotenuse. The hypotenuse, nothing changes there. Opposite and adjacent are specifically relative to one of the angles, specifically one of the acute angles. So we always, when we're doing anything with trig, we have to know which angle are we dealing with. Okay, so we always have to know. And then, say for instance, we're dealing with angle A. Here's the easy way to be consistently right in labeling the angles. And or labeling the sides. We're gonna look at this in what seems like excruciating detail. But what happens is, even when you get to the point where everybody is comfortable and doing a test and they know what they're doing, somebody mislabels the sides or misidentifies the sides as opposite versus adjacent or something like that. That's gonna make the whole problem wrong. So we got to get that right to start. Okay. So here's the angle that I'm using to look at this triangle. That's my perspective for this triangle. It's always going to be one of the two acute angles, never the right angle. Okay. Always one of the two acute angles. An angle has two sides. One of those sides is always going to be the hypotenuse. The other side we always call the adjacent. Adjacent means next to. Technically, they're both next to that angle, but the hypotenuse already has its own special name, so we don't call them both adjacent. We call this one the hypotenuse still. We call this one the adjacent, and we usually abbreviate them. And then the one that is not a part of that angle, that is across on the other side of the triangle, that's your opposite. So if you look at what's happening here, you got the hypotenuse. It's the two legs that end up being called the opposite or the adjacent, and you got to know which one is which for the angle that you're working with. So like on this triangle, for this angle up here, here are the two sides of the angle. One of them's the hypotenuse, one of them's the adjacent side. Here's the opposite side. For this triangle over here, here's the two sides of the angle that I'm working with. Hypotenuse is one of them, the adjacent side is one of them, and the other one's the opposite. Okay, so we're going to practice that a little bit. I'm going to go ahead and number these. And we're going to do 1 and 2 together, and then I will leave you to do the next 5 on your own. Number 1, angle A, all of these, it says the perspective of the marked angle. All of these, that means angle A. Okay? Angle A has two sides. These are the two sides. Now, actually, that's the other thing I need to mention here is, in all of these, we have to assume that the one that looks like the right angle is. So let's go ahead and label those. Okay. So angle A has two sides. One of them is the hypotenuse. That's this one. The other one then is the adjacent. So that's this one. And that makes this the opposite. Now keep in mind, again, that's all relative to which angle we're dealing with. Okay. So if I changed and I wanted to look at things from this angle over here, they wouldn't have the same names with respect to the angle. Which two things would trade? Nope. The opposite and the adjacent, not the hypotenuse. Hypotenuse is always the hypotenuse. Hypotenuse isn't going anywhere. But if I'm looking at things from this angle over here, then this is adjacent to me, and that's the opposite from me. So the opposite and the adjacent would trade if you were going from looking at things from one of the two acute angles to the other acute angle. All right, so right here, there are my two sides. This is the hypotenuse. This is the adjacent. So here's the opposite. Questions on either of those? Okay, so you can go ahead and do the rest of these, and I'll move it down so you can see which one's the right angle. It's kind of the one that looks like the right angle, but there you go. The reason I want you to try these is because I want you to see if you have a tendency to get them incorrect, because that's going to be something that you're going to want to be very, very careful about. Okay, some people have no trouble with this. Some people just keep seeing it wrong, and they get frustrated with that because it's not like it's hard, but still, if you happen to see it wrong, it's kind of frustrating, and you got to be careful about it. Okay, go ahead and check yours against mine. Make sure we got the same thing. If not, see if you can rethink it. The main thing, if not, though, is this. If you got even one of these wrong, that tells you how important it is to be careful with these, and that maybe you need a little bit more practice with this and or help making sure you're identifying it correctly, depending on how many you got wrong. Because again, if you get this wrong, when you look at the problem, if you are incorrect about what's the opposite and what's the adjacent, everything you do after that's going to be wrong. So you got to be very careful. Questions on any of these? Okay. So now what we're talking about is trig ratios. They're ratios. What are ratios? Ratios are fractions, right? So the basic trigonometric ratios, there are actually 6 trigonometric ratios. But in geometry, we just look at the first 3, which are sine, cosine, and tangent. Okay? Now, what I need to point out to you here is this. First thing I want to point out to you. The words are sine, cosine, and tangent. Okay? This is how the words are actually spelled. These are 3-letter abbreviations we use for each one of those. But when we see that abbreviation, we still say the word. So like cosine of 32 degrees, sine of angle A, stuff like that. We say the word sine, the word cosine, the word tangent. We don't say sin ever. We don't say cos. Sometimes people still say tan, but just keep in mind, there's a reason we say something different when we see these, because they're abbreviations for these words. Okay? So the ratio that is identified as the sine. In other words, the sine is just the name of this ratio. In a right triangle, the ratio of the opposite side over the hypotenuse is called the sine. That's the definition. The ratio of the adjacent side over the hypotenuse is called the cosine. The ratio of the tangent is the opposite. The opposite over adjacent is called the tangent. And what this all kind of comes back to, where we can be consistent about saying, oh, this ratio is always defined as such, is because remember that similar triangles have the same ratio of sides. So if I know what the angle is, then other triangles like that are going to have the same ratio of sides. If I know one of the acute angles of a right triangle, and I also know I've got a 90-degree angle, that's angle. So every other triangle that has that angle is going to have the same ratio of opposite to hypotenuse or adjacent to hypotenuse. So similar triangles is what makes us able to do this. Okay? So using the given triangle, find the following. The very first thing I need to find is the length of BC. Question?
It says at the top, like, cosine 0.
That's actually a theta. That's a theta. That's the Greek letter theta, which is just used as a variable for angles very frequently. It's just the same as if it said like cosine X or cosine A. Thank you for bringing that up, though. Okay? So that's the Greek letter theta. I'm very glad you mentioned that, because we didn't talk about that last period, so hopefully nobody was too alarmed by that. We'll talk about it tomorrow. Okay, so what's the length of BC here? 6. It's a Pythagorean triple. 6, 8, and 10. Anytime you see a right triangle that has 8 and 10, or 6 and 10, or 6 and 8, then you know it's, well, depending on where the 6 and 8 are. But as long as they're in the right place, you know it's a Pythagorean triple, and that's going to be 6. Okay? So again, sine, cosine, and tangent are ratios. So very often we write them as fractions. Sometimes we'll be asked to change them to decimals, but that's just like changing a fraction to a decimal. We'll come back and talk about that after we do some of these. So the tangent of, the sine of A, what I'm going to do here is I'm going to go ahead and draw this triangle twice, like draw it a second time, because I would like to be able to label my sides. Here's what I mean. For angle A, here is the hypotenuse, here is the adjacent side, and here is the opposite. Over here, we start talking about angle B, And we've already said the opposite and the adjacent won't be in the same position for B that they are in for A. They're flip-flop. So I'm going to do that here. I'm going to say for angle B, this is the adjacent. This is the opposite. 10 is still the hypotenuse. It never changes. Okay, so, excuse me, for sine of A is opposite over hypotenuse. That's 6 over 10. And that reduces to 3/5. Good question. No. We always use one of the two acute angles. The reason you don't do it with, well, one of the reasons we don't do it with the right angle, it wouldn't make sense. The things that we have set up wouldn't make sense. The opposite is the hypotenuse from the right angle. And then which side's the adjacent? Both of them?
Oh, yeah.
You know? So we always do it from one of the two acute angles in the right triangle. Okay? Cosine of A is adjacent over hypotenuse. So that's 8 over 10, which is 4/5. Tangent of A is opposite over adjacent. So that's 6 over 8, which is 3/4. So then if I want to go from B instead, the sine of B is the opposite over the hypotenuse. So that's 8 over 10, which is 4/5. The cosine of B is adjacent over hypotenuse, which is 6 over 10, or 3/5. And the tangent of B is the opposite over the adjacent, which is 8 over 6, or 4/3. Okay, I'm going to give you a second to catch up, and then we're going to talk about some of these patterns here. Any questions on how I found any of those? Okay, we're basically using the definitions, which is what these are. These are the definitions of the ratios. There are also equations we'll use later. First thing I want to point out, because the opposite and the adjacent trade, if I go from looking at things from one angle to looking at the other angle, from the two different acute angles of the right triangle, since the opposite and the adjacent trade, the sine of one of the acute angles is equal to the cosine of the other. So the sine of angle A is the same as the cosine of angle B. Because what used to be opposite, whatever's opposite for A, is adjacent for B. And again, it works the other way. The sine of angle B is the same as the cosine of angle A. And remember that the two acute angles of a right triangle are always complementary. So one way of thinking about this, well, a couple of different ways we could say what I just showed here. Saying the sine of A is the same as the cosine of B. The sine of one of the acute angles is the cosine of the other acute angle. That's one way to say it. Since they're always complementary, they always have to add up to 90, you could say the sine of one angle is the cosine of its complement, and vice versa. That becomes really important to remember. Okay, so we're going to jump down here, and we're going to look at this one, and also come up with another few characteristics that we can, another couple of characteristics we can discuss here. Let's go ahead and stick with doing it as fractions. Well, I don't know why I wrote sine, cosine. I want to be methodical here, so let's go with sine. Doing the same thing on this one that you did on the last one. Go ahead and fill these in, please. Nice thing about this one is you don't really have to reduce. Okay, so on this one, pretty much you're going to get exactly the same thing you did above because it reduces to this. Remember I pointed out to you yesterday, day before, that the Pythagorean triple 6, 8, 10 can be found by taking 3, 4, 5 and multiplying it times 2. So that's why it reduces to 3, 4, 5. And all of these answers up here is going to be the same. So 3/5, 4/5, 3/4. 4/5, 3/5, 4/3. Okay. One thing I want to point out to you here, we still see the same thing we saw before. These two are the same. These two are the same. The other thing I want to point out to you is the sine and the cosine both have which side of the triangle in the denominator? The hypotenuse, right? Which side of the triangle is the longest? The hypotenuse. So the sine and the cosine will always be fractions where the bottom number is bigger because the hypotenuse is bigger than either the opposite side or the adjacent side. If you have a fraction and the bottom number is bigger, that means the fraction is less than what? 1. The only way a fraction is bigger than 1 is if the numerator is bigger than the denominator, like 7/5. That's 1 2/5, right? An improper fraction. So if the denominator is always going to be bigger, that means we're always going to have numbers less than 1. So sine and cosine of any angle ever is going to be less than 1. Okay? Tangent, that doesn't apply because it flips over. So if it's less than 1 one way, then flip it over for the other angle and it's going to be more than 1. But sine and cosine specifically, you know if you get an answer that's bigger than 1 that you did something wrong. Okay? Now, the one other thing I want to point out to you here before we move on is that one of the things that confuses people about early in the trig, right triangle trig world unit, I guess, is what you're being asked. What we have specifically been talking about just now is how to find the value of the sine of that ratio or the cosine or the tangent if you have all the side lengths. We did not find the angles. We don't really care to find the angles. We weren't being asked to find the angles. We're just saying if I know all the side lengths, which I did here, I knew all the side lengths, then here's what the ratio is of these side lengths. Okay, so if you know the side lengths, you're just setting up a fraction. That's all you're doing. And what happens is sometimes they ask you to give your answer in fraction form and in decimal form. And here's what happens. Students say, okay, I'm supposed to give my answer in fraction form and decimal form. So fraction form is 3/5, and then decimal will be this. No, you don't want to take the sign of the answer. When we take the sign of something, it's the angle. 3/5 is the answer. So if I want it as a decimal, I just do 3 divided by 5 and get 0.6. Okay, so be careful of that. If you're asked for one of these fractions as a decimal, don't hit the sine button or the cosine button or the tangent button. Just change it to a decimal the way we normally change fractions to decimals. Okay? Flipping the page. Bottom of the next page. All right? This is different because we're still being asked the value of the sine or the value of the cosine or the value of the tangent, but this time we're being given the angle, not given the side lengths. If you're given the angle and you're asked what is the sine of this angle, it's just punching it in the calculator. So like sine 23. My answer is 0.39 and I'm done. That's all you got to do for these. If you know the angle and you're being asked the sine of that angle, you just type it in your calculator. I'm having trouble showing both of what I want to show, sorry. Okay, we're going to go to the hundredths. Okay, so like the one below it, cosine of 62.5. That's 0.46. Again, I would be surprised and I would realize something went wrong if I got a number bigger than 1 for either of those, because the sine and the cosine will both be smaller than 1. If people at home, you're using a graphing calculator, please check the mode and make sure it's in degrees, because graphing calculators sometimes default to radians, which is a different way to measure angles, and that will not give you the right answer. So go ahead and try the other 4, please. just real quickly because we need to get to a couple on the next page. Okay. That's what you should have gotten. Check your answers. Okay, so now on the next page, what we do is we start actually using this instead of just saying, what is the sine? Here's some sides, or what is the sine? Here's the angle. We start using that definition of the sine or definition of the cosine or definition of tangent to set up equations that let us find missing sides. Okay, so let's look at that. Number 5 here. All right. First thing I need to do is I need to establish which angles these are. I mean, which sides these are. If this is the angle I'm working with, then X is the which side? Opposite, and 30 is the hypotenuse. So then I go back and I think about those definitions and decide which one of them should I use if those are the two sides I'm working with. Which one should I use? Sine. And then I write an equation using this as my model. I say sine of the angle equals opposite over hypotenuse. And I can solve that equation and I will have the missing side. What would I want to do to solve that equation? What would I multiply both sides by? 30. Okay. Here's what I would suggest is go ahead and get X alone before you touch your calculator. In other words, figure out how to get X alone first and then say, okay, X is alone. This is what I type in the calculator. 30 times sine 38. And my answer is 18.469. I'm going to go to the nearest tenth and call that 18.5. So X is about 18.5. Give it another second. We're going to go ahead and do number 6. First thing I want to establish on number 6 is which two sides those are that are labeled. Yeah, this is the 14 is the adjacent. Y is the opposite. So which of these trig functions am I going to need to use? Tangent, because tangent deals with opposite and adjacent. So I write the equation exactly like that definition. Tangent of my angle equals opposite over adjacent. So tan 25 equals y over 14. And then I can multiply both sides by 14 to get it out of the denominator. And this is what goes in my calculator. 14 times tan 25 gives me 6.52, and my answer is 6.5. And your homework is going to be basically the rest of this page, everything up to the bottom of this page in this packet. Finish everything up to here in the packet. So you got 4 more problems like that. I will try to give you a video in case you want to see some more examples work like that. The previous stuff is what we just skipped on the previous page. Okay. All right, and everybody at home, I'll see you later.